Hey guys, welcome back. So today's objective is I can analyze a graph. So we're going to start off with a couple of scattered plots just to refresh you on looking at the independent and dependent part of it. Now, we'll do this first one together. Now over here, the independent variable is always the x-axis, and since practice time is on the x-axis, the independent variable is the practice time. Now the dependent variable is always on the y-axis, and you can see right here it says field goals made. The field goals made would tell me that that is the dependent variable because it's on the y-axis. Now you remember the conclusion always starts out when the independent increases. That's how it always starts out. So in this case we have practice time. So when the practice time increases, as you can see we have a positive correlation. So it's going up, it's increasing. That means that the field goals made also increases. So again, the conclusion is as the time spent practicing increases, the number of field goals made increases, which makes sense because the more practice, the better you get. So if you practice a lot, right, you're going to have a lot of field goals. If you don't practice that much, you won't make a lot of field goals. Okay? Now, here's the next graph. The next graph represents down here, it says hours spent playing video games, and over here GPA, which is grade point average. I want you to answer the questions on the side over here. Go ahead and do that and come up with a conclusion. Alright guys, I hope you got that right. So the independent variable, again, remember, is always on the x-axis. In this case, it's hours spent playing video games. So that's the independent variable. The dependent variable is the GPA, which is on the y-axis. Now the conclusion, again, remember the conclusion always starts out as when the independent is increasing. In this case, it's hours spent playing video games. So when the number of hours playing video games increases, you can see that we have a negative correlation. So the GPA is actually decreasing. What does this actually mean? Well, if you don't play video games that much, you're going to get a higher GPA. If you play video games all the time, you're going to get a lower GPA because you're playing video games instead of studying, doing your homework, stuff like that. So that's what this is. All right, so let's go to the next slide. So we're going to go ahead and analyze our first graph. This is a car graph. Okay, so let's take a look. Vroom, vroom. So let's go ahead and look at the actual graph. Now remember, over here, the independent variable is always on the x-axis. So the time would represent the independent variable. The dependent variable is always on the y-axis. So the amount of gasoline is the dependent variable. Now, with those two pieces of information, I'm going to give you guys a second to try to figure out what does this graph represent. Go ahead and do that right now. So this graph represents the amount of gas in a car at any given point. Now what we're going to do is we're going to talk about what each of these letters represent. Now we're going to start off together working on it, and then you're going to finish the rest on your own. Now over here, you can see that we're not starting at an empty tank because we're not at the empty part. We're up here. So we're starting with some gas in there. Now, since the gas is decreasing, the only way that gas can decrease in a car is if the car is driving. So in part A, what I'm going to write down is that the car is driving because that's the only way that you can see that it's decreasing. Now, you can see that it's increasing for B. What could that mean? Well, since the gas was low and now it's really high up here, all right, that means that the gas tank was filled. So we filled it up with gas, okay? Then, part C, you can see that it's decreasing again. So since it's decreasing, that most likely means that the car is driving, okay? But then right here, you see that nothing is happening. Nothing is happening at all, right? So there's no gas increasing and no gas decreasing. So how could the gas not be increasing or decreasing? Well, if the car is parked and it's not moving at all, then it wouldn't be wasting gas. So that's what I put down here for D. The car stops driving because the gas isn't moving at all. Okay, now I want you guys to try the rest of these on your own. You can see that there's increasing, decreasing, and there's also horizontal lines in there. So go ahead and figure out what E through K are on your own. All right, so E you can see that it's going up again. So this, whoever's car this is, they probably filled up the tank again. All right, in part F, it's decreasing, so the car is driving. In part G, nothing's happening, so that means the car stopped because the gas is not changing. In part H, it's decreasing again, so he starts driving again. Part I, nothing's happening, all right, so that means the car stopped again. Part J, it's decreasing, so therefore the car is driving. And K, since it's all the way at the bottom, that means that probably the car ran out of gas. So here's the graph, and what this graph has for the independent and dependent are time and water in a cup. Okay, now just so you guys know, here's a little hint for you. If the graph is increasing, that means the amount of water inside the cup is increasing. If the graph is decreasing, that means the amount of water inside the cup is decreasing. Now, there are more than one spots where it's increasing and decreasing, so you have to try to figure out which one of these scenarios would go in these spots over here for A, B, C, and D, and E. All right, so here are the five choices. We got spilling water from a cup, pouring water into a cup quickly, stop pouring water into a cup, water leaking from a hole in the cup, and pouring water into a cup slowly. Now you have to try to figure out which one of these five go into the A, B, C, D, and E. Go ahead and do that right now, and then we'll talk about it. Now, like I said, there's two sections over here where the water is increasing. So we have pouring water into a cup quickly, pouring water into a cup slowly. Over here, since A shows that it's increasing at a smaller amount of time, all right, that means that that's going to be the pouring water into a cup quickly. Over here again, we're still pouring water into the cup, but it's not going as fast as it did in A, so this would be pouring water into a cup slowly. Now part C was the only option for this one because since there's no increase or decrease in the water, this is telling me that this is when you stop pouring water to the cup. Now we have two sections right here, all right, where it's decreasing. This decreases very fast and this decreases slowly. My only options are water leaking from a hole in the cup and then spilling water from the cup. Now the one that would actually take less time would be the spilling, because if you had a hole in the cup, it's going to decrease but not very fast. Over here, D is where it decreases very fast, and then E is where it's decreasing, but it's decreasing slowly. So for D, that's where you're going to put spilling water from the cup, and then E, that's because we had a hole in there and it was going really slowly and it was leaking. So those are the options for this graph. Hopefully you got those right. Alright guys, so here we go on the back. It says which graph represents the situation. This is kind of going to be like multiple choice. So let's look at the first graph, or the first scenario we're talking about. Alright, now the independent variable for this, it's already there, which is time. The dependent variable is the distance from home. Let's go ahead and put that in the y-axis of each of these graphs. Right now, I'm going to read this for you, and then you have to try to figure out which one of these graphs represents this situation. It says that Erica walks from her home to her friend's house, watches TV for a while, then walks back home. All right, so again, the y represents the distance from home. Which one of these graphs represents the situation? Go ahead and try to figure that out. If you need to read it again, go for it. All right, so now the one that actually works is B. Okay, now let's take a look at Y. Now it starts out saying that she walks away from home. She will go into her friend's house. Since she's at home, she's starting at the origin because there's no distance between her and her house, okay, because we're right there. When she starts walking away, that's when the distance from her to her house increases. Now it stops here because this is where she starts watching TV. But then she goes back home, so the distance has to decrease until she finally gets home. All right, so that's why this graph works. Now this graph over here started out okay because she walked away from her house, then she stayed there. But now this is representing that she keeps walking away from her house. Now if she's walking back home, the distance should be decreasing, not increasing. And right off the bat, this one's wrong, because since she started at home, the distance between her and her house should be 0. Over here, it's saying that she's not at home, because the distance between her and her house it's quite a bit. So that's why this one was wrong. Okay, so she's not at home. She stays somewhere. She does go home, stays at home, goes somewhere else, stays there, then goes home. So this one was way off. Okay. Let's go ahead and look at the next one. Now for this one, it says, let's talk about the independent and dependent. The independent is the time. The dependent in this one is going to be speed. Go ahead and write that down. Now it says, as our speedway train leaves the station, it accelerates to its top speed. Then it maintains the same speed until it begins to slow down. Finally, it stops at station B. If y represents the speed of the train, which of the graphs represents this situation? Okay, so again, the train is accelerating, then it stays at a constant speed, then it slows down. Try to figure out which one of these graphs represents that. All right, now this one, it was kind of tricky. It was kind of tricky for me too. Now this one actually is C, because over here you can see that the speed increases, then it remains constant. So the speed that it's going is going to be the same. So say that the speed is like 50, it's going 50 miles an hour. All right, if it stays constant, then it's going to be 50 miles an hour here, 50 miles an hour here. But then it starts to slow down, so the speed starts to decrease. And then once it gets to that station, the speed is at 0 because it stopped. Okay? Now this one right here says that the acceleration increases, but then the speed stops totally. So it goes from 60 to 0 at one time, right? Now that would be bad, because that would be saying that it crashed. And I don't want that to happen. Now over here, what this graph would be saying is that it's increasing. It's always increasing. So the speed is always going faster. All right? That's why C is the best choice. Now this last one you're going to try totally on your own. All right, for this one it says if y is equal to the distance from the campsite. Now, since y is the dependent variable, we're going to put that on the y-axis over there. The dependent variable is distance from camp. Now, you have to read this carefully and try to figure out which one of these is the scenario. Go ahead and do that right now. All right, so the answer is B. Now, let's talk about why it's B. Now, it says right here that a backpacker hikes towards the campsite at a steady rate until he stops. So in this one, he already stopped. So this one is not him going towards it. Same thing over here. He's not moving. This is the only one where he is walking towards camp. Then he stops. So you can see that there's no distance change because he's resting. But then he starts going back, and then we have a 0 here. Okay? Now this one's wrong because it says he's resting. He goes to camp, he rests, he goes away from camp, he rests, and then he goes back to camp. Now this one is kind of funny because this is saying that he's not moving, and then suddenly he teleports. So he's going from here to here. Then he starts walking to camp. So that one was way off, and that one didn't even make sense at all because you can't be in two places at one time. All right? All right, so hopefully you got that one correct. We're going to do more practice like this tomorrow. Have a good day.